Okay, so good afternoon, guys. Madunggan ako. Am I loud and clear?
Good afternoon,
Oh, yes,
sir.
sir. Yes, sir.
Okay, so this is Robot Basics by Festo. Okay. So these are our table of contents. Okay, so elements. So if you have an element, no? So let's say this is referring to any component of a robot arm, perhaps, or an element, no? So one element, or let us say a joint, or perhaps a link, no, it could always be represented by this coordinate system. So in this case, this is in Cartesian coordinate system. Z, no, Z plus ang orthogonal to the plane, then Z minus as well. Tayo na kay y plus, y minus, then x minus to x plus. So it's a 3D coordinate Cartesian system. Then napot siya rotation along its axis. Let's say z, rotation along its x or y. Okay? So muna ginana to ang coordinate system in an element. Okay, so the industrial robot, no, is inspired from the bodies of the human, no. In fact, ang human has the most complex na joints, no, system as compared to the industrial robot, no. So mana siya, no, mana ilahang kuan. Considering that most of the work done by humans are performed by his hands and arms, no. So that's why for the industrial applicability, so ang ginimik lang is the human arm. That's why it's industrial robot arm. Dayon for the linear and rotational movements of these joints, we have this linear joint, or also known as prismatic joints. So linear lang, straight linear lang yung movement or sliding. Then we have this rotational movement, or also known as revolute joints, no? So it is able to rotate. Naka-rotate siya. Whereas kaning prismatic joints is lang, linear, no? Slide lang siya. Okay? Dahil ginapangutana ginako ni always, no? What is the degree of freedom or DOF of the robot? So pag mingan kag degree of freedom, from the word itself is what is the level, no, or degree of freedom of movement. So this is referring to the movement of your robot. And if we're going to talk about an industrial robot, then this is actually the total number of joints. So kung pila tanan ng imong joints, that is the degree of freedom sa imong robot. Example, if you have an RV-2AJ na robot, then it is said that it has 5 axes or 5 joint axes, no? Then that is also the degree of freedom sa kanina robot, 5. If you have the RV-2SD, no, that is mo ng robot na to na nasa laboratory, it is a 6-axis degree of freedom. At the same time, it has 6 joints, no? J1. So makita na niyo dito sa sa laboratory na to, na siya labeling J1, na siya kanang home position, then J2, nasa base ang J1, the J2 is ang shoulder, then the J3 is na siyang elbow, then ang J4, patong sa J6 is the rest assembly na. Rest na niya na assembly. Okay, so nasa yung mga arrow to indicate the home position of its joints. So mga na usually akong ginapangutana, no, sa atong laboratory, particularly on the hands-on of the robot. Pangutanan ako, what is the degree of freedom? What is this robot? So, sa man itawagan ni na robot kung pangutanan mo? What kind of robot is this one? Sa may tubag, guys, tubag. Na yung makatubag?
Robotic arm, sir.
Okay, so this is an articulated na robot, no, robot arm. Okay? So na word yun na articulated because that defines the degree of freedom. Pag may kag articulate, so more words na that would be needed to articulate an article. Kung may article ka, dagan ang word. So diri pod dagan pod ang degree of freedom or dagan pod jay access. Okay? So that's why this is an articulated arm, articulated manipulator, articulated robot arm or industrial robot arm. Okay? So nagin na siya. Okay, so mana itong i-explain ganiya. Then the question is, how about relating it to the human arm? How much is the degree of freedom the human arm without the fingers? Magatagaan mo? Ila ka? Walay apil ang fingers, ha? Pero apil ang hand siguro pagkwintahan.
3, sir.
Ha? 3? So actually the answer is 7. Okay? I-try nyo. So ang shoulder as 2. 2 degrees of freedom. The upper arm is 1, the elbow is 1, the forearm is 1, then the rest is 2. So total of 7. So if you are in doubt, testing nyo. Okay? Then TCP, so familiar na mo sa TCP, no? So the TCP is just a point. It's just a point. It is known as the center of the tool or the tool center point. So kung ang sige magunita ng imuhang tool sa imuhang robot. So mani ang robot flange. No, itong i-discuss the last time, it is the flange. Okay? Then we have the base, ganing nasa ubos. Pag dito sa robot AK naman itong tool frame with respect to the reference frame. So pasabot niya ito, mo yung base by default. Okay? Ito yung reference frame, which is the base. Okay? So it should be fixed. Should not be moving unless otherwise specified na na siya translational na movement. Then for robot types, no? So wala ni dire, no? So ginapangutanan ako paadto na ko dito sa ilalom sa aircon. So actually na Cartesian dito na 3D printer. So it's a 3D printer or 3D milling machine, 3D milling. If it is not a printer, so it was a project, no, previous na project. So pag inani siya, XYZ lang or prismatic lang ang iyang movement, linear lang, to look axis, then it is a Cartesian or 3D Cartesian na robot. Now, if it is cylindrical, one lang. Nani lang siya, no? It has one revolute joint and two prismatic joints. Okay? So, ang prismatic niya ni kining pag-extend diri. Pag-extend o kaning pagnaog gani diri sa ubos. Orthogonal, no? Orthogonal na linear motion. Dahil isa na ka-revolute kaya pagtuyok niya, it could form a cylinder. Okay? So, maning basic na what kind of robot is this one? So, dapat to ba Cartesian, cylindrical, hindi pa kami on spherical. So, in a spherical example, sphere ang iyang ma-form. Wherein duha ka revolute na joints and one prismatic joints para kaning pag-extend of linear extension sa iyang aning end effector or kaniyang magbutang magay ka gripper. An example is a Fanuc Robot L1000. Then another type or kind is the SCARA. SCARA stands for Selective Compliant Assembly or Articulated Robotic Arm. So, the last time example na to is an Epson. Okay, it has two parallel revolute joints to move on a plane. So that's why nindot ni siya for pick and place, mas paspas siya as compared to articulated. But the articulated na arm is more flexible. Whereas this SCARA is only has two parallel revolute joints. Dili siya ka move freely. No? Kuan siya naka-parallel ang iyang joints. Okay? I hope you can still remember tong video the last time. Okay, so mga nagin niyo, nagin niyo kalimtan sa articulated robot arm. So RV2SDB ang sa taas. Ang example is 3S. It's a little bit old na siguro si 2SDB. And we have also this parallel, no? Parallel na type. Kung nakakita mo sa news, isa sa reason nga ang plate numbers sa sakyanan or vehicle, motor, regardless kung car or vehicle or motorcycle, is delayed because ang LTO murag isa ra siguro kay nanay ilang parallel na robot ang ginagamit. Ang advantage niya ni for making plates is mas kusgan na siya kay because it's linear na joints kanyo. Siya linear na joints o prismatic na joints. So, if it is hydraulic, kusgan siya. It is hydraulic driven. Especially kung mag-pressing na siya, no? Mag-press ng plates kay para mag-form. So, kakikita may nakakita sa balita sa sa LTO, mga wapat to siguro nagbulan, ilang ipakita nila ang robot and they are requesting for additional fund na makapalit na sila o additional na robot para paspas ang production sa plate numbers. Kung nakakita mo sa balita, inanito na type sa parallel type. It's not articulated. It's parallel type. Of course, we have this mobile robot. Ang kanina example is a Festo Robotino. Okay? Okay, so coordinate system. Familiar naman ta sa coordinate system. Okay, balik-balik naman sa klase. No? So, the reference coordinate is nasa base. But then again, for every axis, nasa coordinates. Nasa coordinates, including ang imong tool, no, or end vector, or TCP nimo napa siya coordinates. So inana na siya. Okay, so Cartesian, kabalo man ta, no? Cartesian. So ginabalik-balik ni Perminti. Cartesian. Okay, so amo na kung gingon sa inyo ganiya na for every joints na gani siya ay axis or coordinates. Okay? So all bodies has own Cartesian coordinate system called frame. So frame ang tawag. Okay. Of course, these frames are used by the robot controller to calculate the position. We have also joint access. So ganiya, it's a Cartesian access. Sa atong laboratory, na error gamay ato ang robot. No? Ang ma-access lang nato is, ang ma-move lang nato is the joint access. Di ta ka-move sa iyang Cartesian na access because if it is Cartesian, then all of the joints will be moved. So mag-jog lang ta dito, no? I-jog lang nato. At least nidaga na siya. Doon na siya yung minor na mechanical na issue because for the past siguro 6 years wala siya dagan-dagan, so that's why na siya issue mechanically. So take note, sa laboratory, ang ato lang ipadagan is si J1, si J4, si J4, yeah. Si J4, murag nalimtan ang J4 ano sa drawing, ano J4, o si J5. Dumuliyok ang J6 pero di siya kabalik, di siya ka-counter rotate. Wala siya negative, murag puro siya positive. So there's a tendency if we keep on moving the J6 axis, joint axis is siya. Kasi malikos tong itong host, pneumatic host. At palihog as J1, J4, nagdiri na part, o J5. Okay? Then si J2, si J3, kay hapa naman to siya, di na siya kadaog. That's why, that's one of the major issue na i-address pa later. Later na. So, pa-testing sa inyo padagan kung at least nakapa-operate mo sa robot, no? Because most of the time, you are doing the simulation. But actually, the simulation and the actual, kung ano na siya, it has something to do with safety lang. No? And skill in moving the robot. But in the simulation, no, at least you can move the robot even without safety issue. So mara na iyang issue, no? If it's simulated, then okay lang. Okay, so in RoboDK, the joint axis is referred to as theta. Theta 1, theta 2, theta 3. So kung mag-jog mo dito, inyo lang itong i-double click ang robot. Makakita mo itong home na button or align. Below ato na ito ay slide, no? Slider for theta 1 at to theta 6, depending on the total number of axis of the robot. Kung Kuka ba yung brand, 6 axis na Kuka brand, or kung mo siya, Mitsubishi ba, nakapili ba kamong Mitsubishi, or is it an Omron, and so on and so forth. So in our jog na activity sa laboratory, ang i-jog lang natin is the joint axis. Dili ta maka-jog sa Cartesian XYZ na axis. Okay? So particularly, I repeat, J1, J4, and J5 lang only. Okay? Okay, so in Cartesian, aside from the XYZ na points, na po siya gitawag na ABC. Na later, makita na niyo sa actual na teaching pendant na siya ABC. So this is just additional na kuan. Now, our letter A is about rotation around x-axis, no? Dahil ang B is rotation along Y and C is rotation along Z. Take note that the Z-axis is pointing upward. Okay? Okay, so kabalo man taning ko TCP. Mao pa rin TCP. So if you're going to rotate that in the in the TCP na tool, so sa TCP siya mag-rotate, dili siya sa base name. Okay, so it's the same thing. Okay? So the base is also known as the world na coordinate, na just like sa inyong AutoCAD na may world coordinate. Then that's a different case po pag magkuhan ka, himo pagka o new reference frame for their targets. Okay? So we go now to the robot system. Okay? So inana na siya. Tulo na siya ka basic na hardware, the robot arm itself, the robot controller, and the teaching pendant or the teaching box. But that's why yung shortcut is TB, teaching box. But actually it's a teach pendant or teaching pendant. Okay? So yan naging enumerate, no? So this is the teach pendant. Number 3, of course, the robot. Mana to ang number 1. Then number 2 is the robot controller. So the robot controller is not the PLC. It's not the programmable logic controller. Okay? So it is different because the robot controller has servo drives, cards that drives your servo motor sa imong industrial robot. No? For a PLC, it requires additional card, additional module for it to drive a servo na drive. So that's a different case. For a normal na PLC, dili gid siya pwede mag-drive o industrial robot. So that is a special case. I have seen kining PLC is driving a rectangular or prismatic na Cartesian robot, but not an articulated robot. So na case. But if it is an articulated robot, it has its own robot controller. Okay, so kung mabungkag ni mong robot dito, na siya mga gears, na siya brakes, na siya coders, then na siya servo motors. Then it's mostly belt driven. Belt driven siya. Dili siya geared. Dili siya gear and sprocket. It's belt driven. Depending lang, no, unless kung dagko na kayo siya na robot. This is for a 3 kilogram lang na payload. It's around lang using belt na transmission system na belt. Kinsa may nakadrive na diri og motorcycle. Do you know what's the difference between a Mio and let us say famous na ning typical na typical na motor?
Manual, sir.
Oh, sige tawagan na.
The clutch, sir.
Oh, unsa may tawagan na? Say mga ngalan sa mga brand sa motor.
XRM, sir.
Oh, XRM. Yeah. The
Sir.
semi-clutch na semi-automatic. What's the difference in the drive system of the XRM versus Mio?
Ang Mio, sir,
Familiar mo?
under, sir. Then ang XRM, sir, kay manual pagid, sir.
Okay, so very good. Aside pa gid na in reference to our discussion, a Mio is using a belt na drive mechanism. Okay, belt siya. That's why kung papaspasay, mas paspas gyud ang kaning mga belt na mga sakyanan including cars. Basta belt siya, ang paspas siya. Pero pag geared siya, kusgan siya. So that's why kanang Mio, paangaton pa na nimo, apilde na siya sa web. Paangat man, pasakag bukid. Maglisod na siya, kay belt man siya. It is not for the torque, no, it is built for speed, ang Mio. Okay? As well as the rest of the belt na mga drives. Whereas kung geared na siya, whereas for a chain, it is designed for torque. No, torque ang iya. And anyway, those are examples lang. No? Okay. So, nalimtan na to si teach pendant. No, the teach pendant is connected to the robot controller via cable, no? It has several wires inside. Siguro around 16 or so, more than. So in a teach pendant, you can make the robot jog, no? Move by jog. You can teach the position of the robot. You can create programs as well as you can modify parameters. Okay? Then, yeah, mga ni, no? Mga ni ang makita ninyo dito. If you're going to open, na-open mo na mo one time ang kuhan. Ang isa ka joint sa Mitsubishi. That's why kakita mo yan, no? It's using this kind of geared system, you know? It's using harmonic drive gears, you know? Harmonic siya. Then what else? And it is using AC servo. It's using AC servo. Of course, it has encoders to as a feedback mechanism to the robot controller para kabalo ang robot controller ang saan ay actual position sa imong robot. So, nasa yung mga encoders. Okay? And it could be absolute or relative. Okay, so ang ato ang robot controller can be accessed via computer, no? Can be accessed using a teach pendant, no? Or it can be accessed in a local area network na environment. So, naman siya ay RJ45 na port dito or kaning TCP/IP na port. Pwede naman siya saksakan. Okay? Okay, so dili man ni mao sa tong laboratory. Murag similar. Murag mao din sa tong dili dai similar lang sa tong laboratory but not exactly that the same. Kani for sure nata ani this is the MPS robot station. Duha to sila ang isa PLC. This is the modular production robot station. We have this one in the laboratory. Murag inani similar sa ato dito sa lab. Pero mas dagan pa ani. Okay. We have this prismatic na rectangular na partition na robot as well as the handling stations na duwa. Yung robot din we have the conveyor system diri so gamay ra ni siya mas dagan pa dito sa tuwa. Pero actually murag mao dai ni nakuha na model MPS 500. Murag gamay lang ang nakita. Murag mao ni siya. You try to read the labels dito, murag mao to MPS. Then na-discuss na po nato ni sa Amatrol. This is the flexible manufacturing system wherein one articulated robot with translational motion is controlling or feeding the CNC. Kaya ang CNC mo dugay mo gani siya man so butang niya diri sa basic input na material diri sa imong CNC pag-release na niya pa siya time mag-input na po dito sa next na CNC. So para mas mas economical because ang isa ka educational na siya na price around 5 million. Try to read dito sa taas na siya costs the flexible and the MPS, the modular production system na robot is cost 5 million. So kung duwaon mo then it becomes expensive. Okay? So napo yung na station, wala na, no? Actually, this is just showcasing of the products of Festo. After all, this is Festo na slides. Okay. Okay, so iFactory. Okay, so we're done with this slide. Then let's proceed to the next slide. Makita na ikaduha na slide, Mitsubishi robot.
Yes, sir.
Okay, very good. So morning next na to na slide. Okay, so let's proceed. So these are the table of contents. So this is the different types of So ang ato ang robot sa taas RV2SDB. So similar lang sila kamay na modification. So pag pangutanon ka, what type is this? Then it is an articulated robot arm. What is the degree of freedom? 6. So sabot na tana, it has 6 joint axes. Of course, the weight is around 37 kilogram. Parehara this is isa ka sako na ano, or mas bugat pa ba ang isa ka sako na simento. Then the maximum payload, so it's 3.5 kilogram. Then the gripper flange reach, so wala kay tool dire. It's ang pinakalayo niya maabot, yang reach is 642 mm. So sama na wala kaabot og isa ka meter, wala isa abot isa ka metros, because 1 meter stick is 1,000 mm or 1 meter. So isa ka abot isa ka meter. And the speed, maximum speed is 5.5 meters per second with repeatability of plus minus 0.02 mm. Then katong controller type niya is CR1D. Then it's using an absolute na encoder. Then it's using an AC servo motor. It's using an harmonic gear drive. And it has a gripper that is pneumatic and electric because of the sensor. Pero ang katong pag-grip niya, pneumatic. So that's why kung mapalong tong compressor, na dili gid siya ka grip, no, because it requires compressed air. So we skip this one because this is for the SCARA. Okay, so balik-balik, no, the control panel or the robot controller, it has a control panel. So mani ang front panel. So as of now, nasa error, nag-display siya no operation. I don't know. Wala pa na-resolve sa testo ng anong no op ang display niya. Then makakita ka og manual o automatic. So by default sa lab, manual lang sa ta because automatic is used for computer na programming na. Okay? Manual lang sa. Then makakita kag SBO, that is shortcut for servo on. Nasa 1, then SBO off, servo off. Kung masiga ang off, then it is off. Kung masiga ang on, green, it's on. Dayon, you have the teach pendant connection. So dagan-dagan yung buslot dia. Diyan may saksak ang cable. Pag tanggalon niya ang cable, na pa siya sliding na switch na marag sliding mo. Di mo siya pwede birawon unless you're going to slide the switch in the cable para siya mo mechanical release. Then the RS-232 for the communication. And we have here a battery, similar to motherboard na battery sa computer, but not the same ang size. Dire kay murag nakalimot ko siyang size, but it's bigger than AA. Dili siya, it's a lithium ion the type, but it's not an 18650 na battery. Pero nabilong siya sa lithium ion. Okay, the emergency stop and so on and so forth. Okay, so just read this part, no? Just skip this part kay wala pa ta naka. Actually dili ni siya ma-perform nito sa controller, robot controller, the up and down dili siya ga-change, no opera yang gina-display. So there's something still wrong with the robot. Okay, so pag mag-start ka og program, mo ning i-automatic di mo siya. Okay, so we're not going to follow this step because dito pa ta sa manual. Okay, so just read lang if you're interested in the steps on programming. Okay. Okay. Adere, ginaingon niya, there will be error. One way to reset the error is to press reset. Okay. So we go now to the teach pendant, or also known as TB or teaching box. Mga ilang terms ako. Okay, so this is the teach pendant or the TB or the teaching box. So na siya emergency stop. Then it has LEDs as the power indicator, as the enable indicator, servo indicator, and the error light indicator respectively. Sunod na sila. So dili pasabot pag kung gusto ka na i-enable mo ang power, pislito ni mga F1. Dili na siya mao. It's just an indicator lang. So happen lang na disalign. Except for the error. No, pag mag-error siya, then gusto ka mo balik what's the details of the error, then you press F4. Okay, dili mo siya magsiga. Then you have the function keys. So the function keys is responsible for changing the menu. Naman siya yung menu manggawas dire. Upat ka buok. So kung gusto ka na tutunan mo lisay, pangitaon mo ang close, so you just keep pressing the function para magawas ang close dire. Since there are only 4 menus, ang corresponding keys rin niya is kaning F1, F2, F3, and F4 respectively. So kung nai kuan diri butang na menu detail, so F1 na siya. Kung nai butang diri na previous, F2 na siya. So upat lagi na always because it corresponds to F1 button, F2 button, F3 button, and F4 button. If you're going to change the menus, then that's a function. Dayon, we have here the gripper or the hand, the press hand. Dayon, ang C minus is for the close position. C plus is for the open. The opening of the gripper or the hand. Then pag mag-jog ka, click naman eh. But before you can jog, make sure that the enable button and the servo button is on. For the gripper, pwede ra ang enable button ang i-on. Okay? Then this is for the emergency stop. Of course, this is the LCD display panel. And this is for the reset button. This is for the execute. For a certain program you may execute, you need to press this one. But we're not going to make a program first way. We're going to need to jog lang. Then clear, if you want to erase, then the direction arrows for the submenus, no, up, down. Then we have here buttons for the access, X plus or J1 plus, X minus or J1 minus, J2. So ato padaktan din na pwede kayo maklaro. Anyway, madumduman na rin dito sa kuan. Kita naman niya sa laboratory on Wednesday. So X plus or J1 plus. So dili ta magamit sa Cartesian. Atong gamiton is the joint. So J1 lang o J minus. Dayon si J4 o si J4 minus o si J5 and si J5 minus. Okay, respectively. So mara na siya. But anyway, may experience na niya dito sa lab. Okay, so ang kanipong numerical na alphanumeric keys, pareha rin sa katong mga keypad types ng mga cellphone. No? Wherein ang isa ka key is corresponds to A, B, C. No? So kung kabalo mo gamit og keypad na type na smartphone, cellphone, then same ra na principle. Nala siya pag-change from number to character. Change, click nimo dito. Then, before ko malimot, na pwede siya speed override. No? So, by default, 3% ang iset na ko dito. Then, pwede, you can go as high as 50%. Because the last time, 100% siya, nabako na ng robot, wala na kasaka. So, we're going to limit our speed override up to 50% lang. Okay? So, pag magbasa po ka sa likod, this is the enable switch or the TB enable. And this is the dead man switch. Color na dito is yellow, but there is white. Yellow ang color niya dito. Okay? So, on the requirement, before you could move the robot, you must enable the switch, especially in manual na position. Nasa manual, dapat enable mo siya. Pero sa automatic, dapat palungon mo siya because it is automatic. Then for the dead man switch, no, you need to hold it in the middle green zone. So dili mo abot diri sa kaning sa tunga bitaw, pagunita na nimo, pag imo na siyang birahon either side, balon baka tuon, di ka dapat moabot sa red na button, red na area. Dapat in between kaning duwa ka red, no? So dapat green lang ka na. So anyway, I'm going to demonstrate as I'll call your name sa lab. Dapat matibantayan, dili nimo siya moabot sa red na area, dili na sa green. So maano siya, no? Activate the teach pendant, switch the key into manual mode. So manual, dili sa automatic. Then enable the teach pendant. So ang TB na enable nimo diri sa likod. Dayon, maano dito nalimtan. Okay, sumunod. Akani dai, this is the kuan. The next step is before nimo ma-on ay mong servo, you need the kuan kaning there is dead man switch. Hold the dead man switch in the middle zone on green. Yes. Nay nangutana dia. Nay nangutana. Wala. Sige, ako na sa mute tanan. Okay, so ano siya, no? Patbantayanan before you could turn on the servo, you must enable the TB button and the dead man switch in the green zone, not in the extreme position. Dayon, you press dayon the servo diri sa mount teach pendant. Okay, so kinahanglan nimo i-gunitan siya always. Because if you're going to release the dead man switch, the servo will turn off. It is a safety na mechanism. Okay? So pag mag-jog ka, of course, the servo is on na and TB enable is on na pod. Makakita din ka sa aning menu nimo diri. By default, the function is makita nimo XYZ tool, XYZ, then cylinder. So if you're going to go to XYZ, dito ka sa click nimo sa F1. Dili nimo i-click si F2 kaya dito ka sa tool. Kaya di po ka mo-click sa F3 kaya diri ka sa 3XYZ. Di po ka mo-click sa F4 kaya dito ka sa cylinder, in which the robot is not a cylinder, it's an articulated robot. So pag i-click mo din mo sa XYZ, ang next din po din mo makita diya joint. But take note sa joint rata mag-jog. No? I-jog na to ang joint. Dili ta mag-jog sa XYZ, kina siya error. Okay? Then we can perform the speed override starting from 3% up to 50% only. Di na natin 100 kay the last time mag-error siya pag 100. Okay, for the hand, no? So sa hand, dili kinahanglan ng servo. So pwede nimo palungon si dead man switch. I-release din. Pwede lang ka mag-click sa hand as long that the enable button sa likod is turned on. Pwede mo siya. Then pag C minus, naka-creep siya. Then the C plus is release. But anyway, you try to look at the response as you press the button C plus or C minus. Okay? So wala na tayo na topic because though pwede ra gyapon pero di man nato ma-teach ang robot because teaching position requires katong XYZ niya na coordinates, no? So dapat full ng mga joints, wala error niya. Kaya namin siya error, so it will not it is not allowed, no, to make teaching a certain position because by default it is Cartesian XYZ siya. Okay, so if you're interested, you just read this in advance. Ano siya? Okay. Position teaching method. Okay. Okay. So that's it for the basic one sa to ang robot. Okay, so I'm going to share a PowerPoint presentation. Ito sabi ko. Okay, naram gapon sa kuha ng mas better ning PowerPoint presentation as compared to PDF kay napa siya slideshow. Okay, makita niyo si kuan by robot kinematics. Mana na ba tani? Wala pa. Mana na ta sa robot kinematics? Wala pa man siguro, no?
Wala pa, sir. Wala pa.
Wala pa, sir.
Okay, so let's continue. So what is kinematics? So it is the branch of mechanics concerned with the motion of the objects without reference to the force or forces which cause the motion. Okay, so walay appeal ang motion, walay appeal ang forces. Ito ang we'll just be dealing with the kuan lang, motion, no, saan may pagliyok. Of course, if you say what is robot kinematics, it's actually the studies the relationship between the inventions and connectivity of the kinematic chains. Sabutan niya katong yang sumpay-sumpay sa yang links, sa yang arms, sa yang shoulder, rest assembly, mga itawag, no? The connectivity of the kinematic chains and the position, velocity, and acceleration of its links in the robotic system. So, manotice niyo diri, wala na mention ang force. Yung mention lang niya is position, velocity, and acceleration. Okay, so that is kinematics. So, duwa ni siya, if you're going to say kinematics, then it is forward and inverse kinematics or direct kinematics, referring to forward kinematics, and given are joint angles and links, no, or what is known as the joint space. And then the one, what you are going to compute is the position and orientation, no, the end effector, the gripper, relative to our reference frame, which is the base frame. And this is in Cartesian space. Pagbingon ka joint angle, katong joint niya, no, naman siya katong theta 1, katong sa robotic theta 2, mato yung mga joint angles or J1, J2. Ang links, ang katong yung mga length sa yung arms, no, and rest and joints, no. It's the link, the length of the links between the joints, ano siya, manang links. So, mura ginani, theta 1 or J1, theta 2 or J2, so on and so forth. This is the joint space converted to or computed as forward kinematics para makagawa sa imong X, Y, o Z, or in Mitsubishi na one, the terminology, it's A, B, and C. The A is the rotation along X, the B is a rotation along Y, the C is rotation along Z. So conversion from joint to Cartesian space. Okay? Whereas if you're going to say inverse kinematics, then ang given na to is the Cartesian space, the XYZ, the position and the rotation of that TCP na to or the end vector relative to the base frame. So compute for the joint angles, no, including the links, no, though given ang links, gina-compute lang is kanilang yung joint angles na sipyat niya, wala na na-appeal ng links. Given naman ang links. Okay? So, dere, XYZ Cartesian man as well as the rotation along the axes XYZ respectively. So inverse kinematics computation, dapat theta, theta 1, theta 2, and so on and so forth. Okay? So wala na ni-apply ang links. Okay? By default, should be given. The dimensions of the geometry or dimensions of the robot is given. So pwede na ni. Now if you have joint angles to position, then that is forward kinematics. If it is XYZ Cartesian into joint angles, then that is inverse kinematics. Okay, so example, we have here examination drawing. So this is a two-link manipulator. So dili the same sa ito ang Mitsubishi. Okay, duwa raman ka link 1 and link 2. And it's in a planar kinematics. Sa pasabot, XY lang. Di ba? Gano'n, panguntahan naman ako na asa na plane nag-move ang rectangle sa robot. Drawing the rectangle. So, dugay kay sabton. So, dere, klaro gid siya, planar. Say planar, it's moving in a plane, flat surface. Ang surface na to is XY na axis. Okay? So, planar kinematics. What are given? Of course, the length of each link, given yun. Then the angle of each joint, defined siya. Defined. Nasa sa dapit. Then, what you can find. So, ang imong isolve is the position X and Y. So, saan mo ipag-solve? So, dere, ang solve mo na to is ang X lang sa. No? So, mga mo na ito ang point, the TCP point, the total center point, sa itong end effector, assuming. So, muna na ito solve is the X. So, mga mo na itong X. So, kung gagawin na to ang X, simulan na to X1 prime and X prime and X double prime. So, ang X prime, una niyo pag-solve is money. No? Kadumdum pa mo sa inyong trigo. How do you solve for the length of this one? Kaning nasa adjacent. Diba? It's L1 cosine theta 1. Because cosine is sukatoa adjacent over hypotenuse. Okay? So, para ma-solve mo ang X, which is actually the ito ang adjacent. Then, ang L1 na ito, manang hypotenuse, no? X1 over L1 is cosine theta. Manang ka, adjacent over hypotenuse. So, this is X single prime lang sa. No? Then, followed by another X, kining remaining na X. So, dire. So this time, ang right triangle is duwa na ka-angle, no? Theta 2 and the theta 1, kaning dire. So that's why cosine theta 1 plus theta 2 na siya. Okay, the same. We're going to get the adjacent para makuha na itong length na X, assuming double prime. The sum of X prime and X double prime is actually the X. Okay, so mga na siya. Na may pangutana? Kung maglibog mo, just review your trigonometry. Then next is the y. How do we solve for the y? Okay. So let us say kanila sang y prime, no? Isa lang sa y. Duwa man ka component ang y. Diri na part o katong dito sa taas na part. Okay, so sa diri lang sa na triangle, since sumana naman ta sa cosine, sine na pod. So katuwa. So opposite over hypotenuse. Ang hypotenuse na to is L1. So ang opposite na to is actually the y single prime. Y prime lang sa. So y prime divided by L1 is sine theta 1. Ang opposite niya is the y prime divided by the hypotenuse, which is the L prime. Yes, na yung istorya? Na naglagarat Ito pa na ako. Okay? Then for the next na part, kanin diri sa taas, the same thing. Instead na cosine because there is a x or adjacent na side, dili na punta sa opposite na side. Okay? Same thing, theta 1 plus theta 2. Kaya naman kay angle diri. Theta 1. Okay? And then finally, you have now the forward kinematics na formula, which is the x and the y. Maraming kinahanglan. Given ang, of course, given ang mga lengths ng L1 and L2, as well as the theta, the joint angles. Given siya. Pag mo na naibutang diya, ang mga values, you can get the x and y na values sa imuhang Cartesian na coordinate system. Na may pangutana, let's proceed. Simple lang ni. Okay, nabaligtad ni. Okay, so nabaligtad siya ba anyway. So this time, it's inverse kinematics na. So the same gyapon na drawing, ang given is the length of each length and the position of each end the vector. Given ang imuhang xy na coordinates, of course, given ginamang L1, L2. Then, ang imong pangitaon is ang angles, the theta 1 and theta 2. That's why it is called inverse, because it's the other way around of the forward kinematics. So, saan mo na siya? So, let's draw several triangles, no? Where, let us say, in this side, na kay BC and AC. So, solve lang sa nimo ang BC and AC. So, again, it's just a right triangle. So, ang BC is actually the adjacent. The BC is the opposite. So, that's why ang hypotenuse ni L2 man, L hypotenuse times sine theta. The AC is the adjacent of the angle, theta 2, which is L2 cosine theta 2. And additional is nakidako na triangle, kanilang gamay na triangle rather, no? Dire pa dong sa ABC. So tangent alpha is equal to opposite over adjacent, no? Manatuwa, so katuwa. So opposite is kaning BC. So gisolve mo itong BC, which is L2 sin theta 2. Dahil ang adjacent is duha ka component, the L1 plus kaning AC. Solve naman nato. So L1 plus AC. So mana to ang mga preliminary na mga equations. So we have equation 1. Then of course, the tangent beta kaning dako na triangle is just opposite over adjacent, no? Y over X. So, kay second equation. Then, going back sa inyong forward kinematics to solve naman ni maning X of Y. So, you have already this equation 3 and 4. Okay, padumdum pa mo. Ito niya. Then, this is one of the methods is we're going to square both sides of the equations 3 and 4. Kasi square ni mo dayon i-add ni mo later. Pag square ni mo what's the square of x? This is x squared. It's the square of y is y squared. Total din naman siya, x squared plus y squared. Okay? On the other hand, kay right side equation, yung mo siyang square, then i-add ni mo. Then this is now the simplified result. So your assignment is you're going to submit on Wednesday the handwritten assignment, solve it again, the inverse kinematics. This time you're going to use cosine law. So kani dili ni cosine law kung gigamit. But if you're going to remember yung cosine law, kani siya may mo ni siyang minus diri, minus. May mo siya x squared plus y squared is equal to L1 squared L2 squared minus 2L1 L2 cosine of something. Dili lang siya katong theta 2 something. Okay? So para actually the cosine law has shorter na solution rather this one. Okay? So, that is your assignment. Remember, Okay. So, since ang atuang method is not using cosine law, then it is required to square both sides. So, inani pag-square. Okay, pag-square na ni mo, inana ang resulta. Giunsa na ako na, sir, giunsa ba na ni mo? Wala lagi na nakasulat. So, I'll teach you. No? I'm going to stop sharing this one. Teach you how I did it. So, diri ko sa Wolfram Alpha. O, kita niyo si Wolfram Alpha, guys?
Yes, sir. Yes, sir.
Okay. So, Wolfram Alpha is a very sophisticated computational intelligence. So, okay, ni si Wolfram Alpha. So, since dili naman mo first year, actually, mas in first year, pwede po magkabalo mo gamit sa Wolfram Alpha. This is my technique way back then when I solved my assignments. Gamit ako sa Wolfram Alpha or other mathematical, gitawag niya, symbolic computers. It has the ability to compute symbols rather than numbers. Kung numbers lang, pwede rin na gamitan ng calculator. Pero if it is symbols, then you need a symbolic computer. Okay. So, mga man yung ganiya. So, I just simply type. Sige, so, type. Di na ako memorize. So, dili lang ako mag-sample. So, sa math na input, pwede ka maka-type ka o let's say, cosine. Type mo cosine. Di tayo gusto ka na kay alpha, kaning Greek letters, click mo na siya. Dari kay theta diri. O, di ba? Pwede ka 1. Okay? So, and so on and so forth. Kung mag-square ka, balik ka diri siguro. Namin na yung square. Pwede mo cut and paste din sa cosine di ha. Cut and paste din mo sa sulod. Cosine square na siya. Okay? So, pwede na. Dayon, kung gusto po ka na-solve mo siya o complicated na answer, pwede mo na siya ka-integrate. Pwede kayo. So, dili po ka sa integration. Integrate. Kag-integrate. Integrate. Then, kag-sign x. Pwede na. Respect to x. Pwede na siya, guys. Pwede na niya mag-1. But then again, ito ang topic is kanila. Simplify niya ning generate na to na equation is square. So, na siya answer. Automatic answer. So, I will not require it to square this one because sa time pa man is algebra. So, dili naman mo algebra ron. So, sometimes, so cosine law na inyong assignment. That's why it's not this one. I'm just showing you na what technology could simplify the very tedious na solution. Okay? So, na may pangutana. So, minato ra na ko sa pag-solve. Kag-integrate Sige ka mag-integrate Sir, maka-integrate ba na siya og lisod kayo? Oo, ka-integrate ni siya. Okay? Integrate na ito lisod kayo. Let's say from 0 to infinity. May infinity na word. Symbol na siya. Then balik ta sa exponent. Ay, sa'yo, yati. Exponent. Sorry. Tidak ko. Exponent. Okay, dire dapit. Then exponent nimo is say x. No? Dahil negative siya. Or, square pagid. Negative. No? Dahil dx. So, integrate niyo guys. Maski patabang po mo sa inyo ang engineering na kaila, di kami sila ka-integrate ani. Because unless natudluan sila, this requires double integration. Single integration na nasa ka na double man. Humana ang property. Ina na siya kalisod. Kinanglan pa rin mo siya mag-solve using double integration. And the answer is square root of pi over 2. Okay, so double integration na of using coordinate system, a transformation of coordinate system. But anyway, so let's continue sa itong klase. Marag na naman ta diri ba? Makita niyo guys ba? Ano ta diya?
Yes, sir.
Okay, so doon na ito man. So mana siya. So since na-simplify naman, man to na-simplify man no? If you're going to square this one, it is actually money. Similar to cosine law. So mga na ni siya, no? So you just solve for the cosine theta 2. So iura na siyang i-transpose sa negative as sa pikas na side of the equation, then you have cosine theta 2. Then lastly, wala pa, pwede na man. So kaning kuan relate din na to si theta, si alpha, and si beta. So you have this one, where in fact tangent theta is equal to nani by the property of tangent beta minus alpha. Pwede naman siya ma-expand into this one. So therefore, na-solve mo ni ganiya si tangent alpha, si tangent beta, na-solve mo ni ganiya, mo na na-substitute there. Okay? So, ano ni ang equation pag ma-simplify na nimo. And lastly, mana gini ang output. So, theta ang input nimo is ang x lang ug y. So, ang given na ni xy of course by default the link lengths. Dayon ma-solve na nimo ang theta 2 as well as theta 1. But theta 1 cannot be solved unless ma-solve na nimo si theta 2 because input siya sa imo theta 1. Okay, so inyong assignment dapat same ra gyapon ta og derivation sa answer. Inyo lang it's using the cosine law. Okay? Sinabot ta? Okay, so napo may pangutana. So dapat theta ang output. Okay, kaning theta kay mao man ni ang joint angles with respect to every joint. Kaning origin na joint, kaning A na joint. Namin siya. Okay? So kung wala na may pangutana, ato nang i-stop recording. Wala na may pangutana? Para di
So
ra
far, sir.
kita sa itong recording. Stop recording.